think back to last year when we talked about trig. Everybody but the Cheyennes were in my class, I believe. You guys are so lucky. So, if we have a right triangle, we call this theta, we know that sine of theta is the opposite side divided by the hypotenuse. But what if the hypotenuse is 1? Then it's the opposite divided by 1, which is just the opposite. So we can erase the hypotenuse if it's 1. Well, is the same true of the cosine? Adjacent over hypotenuse. If the hypotenuse is 1, then the cosine is just this length here. And the sine is just that length here. All right, well, if I had a right triangle and I knew that the hypotenuse was 1 and I knew that the base angle was 30 degrees, what would the opposite side be? Well, it's the sine of 30 equals something over 1, but that 1 doesn't come into play, so all I have to type is the sine of 30, which is 1/2. Okay? So we actually use 30, 60, 90 triangles quite a bit. 30, 60, and if normally this is a 2 and that's a 1 and this is the square root of 3. But we decided we don't like those triangles because when the hypotenuse is 1, we can do half the work. So we're going to divide everything by 2. So 1 is the hypotenuse, 1/2 is that side, and root 3 over 2. We can do the same thing with the isosceles right triangle. 45, 45, 90. And normally it's 1, root 2, and 1. We're going to divide everything by root 2. But I can't leave it like that. So what do I need to do? Times it by root 2 over root 2. And the bottom square roots cancel, and we just get root 2 over 2. So those are the pictures that are at the top of your worksheet. It's the normal reference triangles, but we've divided by the hypotenuse to make them easier to work with. Okay. Then we have a picture of the unit circle. And pi over 6 is the same as 30 degrees, and then 45 degrees, and then 60 degrees. And of course, this one is 0, this one is 90, this one is 180, 270, and this one doubles as 360. How do we number the other angles? If we rotate through quadrant 1 and into quadrant 2, so if we rotate this way, what's that first angle going to be? Right, add 30, add 15, add 15, add 30. That's the pattern. So this would be 120, 1, 35, 150. So we add 30, add 15, add 15, add 30. We start over. Add 30, 210, add 15, 225, add 15 is 240. What are the three angles in quadrant 4? 300, 315, and 330. Okay? Well, now we want to do the same thing in radians. We know straight up and down is pi over 2. This one is pi. This one is 3 pi over 2. and the full circle is 2 pi. Okay? And then this rotation here is pi over 6, which means that this rotation is also pi over 6. Well, what is pi in terms of sixths? 1 pi. What is that in terms of sixths? How many sixths are there in 1? 6. So this is really 6 pi over 6, and we're going to backtrack 1/6. What is 6 over 6 minus 1 over 6? 5 over 6. So this one is 5 pi over 6. Everybody understand that? Well, what if we were to go the other direction and add 1 over 6? What? Well, what's 1 more than 6 over 6? 7 over 6. So this would be 7 pi over 6. Okay? And then if we go from 2 pi and we backtrack 1/6, what is that going to be? And how did you get 11? 12. So this is 12 over 6 minus 1 over 6 is 11 over 6. 6. So this is 11 pi over 6. Now, another thing you need to remember is that all of those angles have the same reference angle. Reference angles, you do the rotation, and then you take the shortest angle back to the x-axis. So here is the reference angle in quadrant 1. It's the same reference angle in quadrant 2, which is the same reference angle in 3, which is the same reference angle in 4. So it's all of these angles. They're all 30 degrees or pi over 6. And this circle can be as big as we would like. So we call the radius of the circle 1. And notice in all of those angles, we can create a triangle. And on that triangle, that was a weird way to say it, the hypotenuse is 1. And that's what we're looking for. So let's actually draw that in quadrant 1. It makes a little bit more sense. All right. So this is our triangle. It's a 30, 60, 90 triangle. What is the length of the x value, the length of the ground of that triangle? Not 1. It stops before it gets to 1. It's the one that's found in the reference triangle at the top of your paper. What is the adjacent side to 30 degrees? Root 3 over 2. So the x value is root 3 over 2. The y value is adjacent to 60 degrees, which is 1/2. Now that exact triangle is found in quadrant 2. But there's a difference. Which is negative? Did you say x was negative? Oh. X is negative. Good job, Caitlin. So negative root 3 over 2, comma 1/2. What about in quadrant 3? They're both negative. So negative root 3 over 2 and negative 1/2. And in quadrant 4, the y value is negative. So root 3 over 2, negative 1/2. Okay, let's go up to 45 degrees. So 45 degrees, what are the side lengths? They're both root 2 over 2. So the x is root 2 over 2 and the y is root 2 over 2. In quadrant 2, 135 degrees, negative root 2 over 2, comma root 2 over 2. Okay, quadrant 3, They're both negative. Good. And quadrant 4, just the y value is negative. Oh, that's positive, sorry. Okay. Now if we go to the 60-degree angle, so we have this triangle. What is the x value of that triangle? The x value is 1/2. The y value is √3/2. So we do the same thing in quadrants 2, 3, and 4 with the correct negatives. Okay, we missed some. What are the x and y values at 0 degrees? 1, 0. At 90 degrees, 0, 1. At 180, negative 1, 0, and 270. Oh, I put these in the wrong place. I'm sorry. So this is 0, negative 1. All right. Well, the nice thing about the unit circle is we pick a random triangle. Let's pick this one here. The reference angle is 60 degrees, and the hypotenuse is 1, and that's the key. The hypotenuse is 1. So the sine of 60 degrees is just the y value. Normally, it would be y value divided by hypotenuse. The hypotenuse is 1. So you can't quite see it up here. Y is the sine of theta, and x is the cosine of theta. And all you have to do is read off the number and you know its value. Does that make sense? So if I wanted to know the sine of 150 degrees, I rotate until I hit 150, and then I create this triangle. What is the y value at 150? 1/2. That was easy. What is the cosine of, well, let's do 5 pi over 3? Well, 5 pi over 3 would be, it's the same as 300. Oh, we didn't do that, did we? Okay, I'm sorry, guys. Let me back up. I'm getting ahead of myself. Okay. All right, so if this angle is pi over 4, then we're going to take 1 and we're going to take off 1/4. What is 1/4 less than 1? 3 pi over 4. So this angle is 3 pi over 4. What if we take that same angle and we add it to 1? So 1 is 4 over 4, plus 1 over 4 would be 5 over 4. 5 pi over 4. And if I took 2 and subtracted 1/4, what would I get? Well, what would 2 be in terms of fourths? 8/4, and if we take 1 away, 7 pi over 4. You were right, Hannah. I was just ignoring you. For some reason, you in Brooklyn, I ignore you. I don't know why. Not on purpose. Brooklyn has all these great ideas, and I don't know. Mental block. They all tend to come true, but not because Brooklyn asked. Okay. So, did I bump my... I did. Okay. So, that's 1/3. If I start at 1 and I back up 1/3, what would that equal? 2 pi over 3. I was listening, Hannah. If I add 1/3 to 2, what do I get? 4 pi over 3. And if I subtract 1/3 from 2, 5 pi over 3. So now the cosine of 5 pi over 3 is just the x value at that angle. Does that make sense? No? Did you get it all labeled? Okay, if you have it labeled, then you don't have to do any thinking. So the sine of 330 degrees. I just find 330 degrees, which is right here. And then I look, sine is the y value, so the answer is just -1/2. Okay? Well, what if the angle isn't on there? Well, it depends on what you mean by not on there. If I were to say 495 degrees, what is equivalent to 495? Minus 360, and that would be 135. Is 135 on the list? Yes, so what is the cosine of 135? The x value at 135 is -√2/2. So if the angle is too big, just subtract 360 or subtract 2 pi, and you can figure it out. For instance, what about the cosine of 11 pi over 3? Well, that's too big, right? Halfway around the circle would be how far? 3/3. All the way around would be 6/3, 1.5, 9, 2 would be 12, so we're actually 1 less than 12, which puts us in quadrant 4 at the angle 330. No, these are thirds, not sixths. So it would be 300, which would be -2. Okay? What about negative angles? What about sine of -3 pi over 4? So that's actually really easy. 3/4 is from there to there. So -3/4 would be the same rotation in the opposite direction. So the sine is going to be -√2/2. Okay? You could also just add 360 or add 2 until you get a positive number. That would work. Yeah, it doesn't really matter in that case. What about tangent? So we decided that opposite equals y and adjacent equals x. So all you do is the y value divided by the x value. So the tangent of 45 degrees √2/2 divided by itself is 1. That was easy. What about the tangent of pi? Nope, nope. Y over x. 0 over -1 is just 0. What about the tangent of 90? 1 over 0, which is infinity. It's error, undefined, because it's too big. Okay, those are pretty simple. Here are the two that are tough. Really, the only tough thing you're going to do today. The tangent of, let's do something like 300. So 300 degrees is this. And here's how I want you to write it. √3/2 divided by 1/2. For some reason, if you write it this way, you remember the rule. If you write it as √3/2 divided by 1/2, you forget the rule. I don't know why. How do we divide two fractions? you flip the second one, so 2 over 1. Oh, and this one's negative. I'm sorry. And now what do we do? The 2's cancel, and we multiply, and the answer is just root 3. Well, negative root 3, because the 1/2 was negative. Okay? So 4 of the answers are either, of the tangent answers, are either going to be root 3 or negative root 3. What about the tangent of 240 degrees? So that would be this set of fractions. Negative root 3. Oh, wait, that's the same. Yeah, it would be positive. Let's do 210. So the tangent of 210 is going to be negative 1/2 divided by negative root 3 over 2. We flip the second one, 2 over root 3. Now we multiply. The 2's cancel. What am I left with? Well, the negatives cancel. So 1 over root 3, but that's a problem. You times by root 3 over root 3, and we end up with the square root of 3 over 3. I don't know how I just did that. So really, if you're doing tangent, you're going to get 0 if it's at 0 or at pi. You're going to get infinity if it's at 90 or 270. If it's a 45-degree angle, you're going to get 1 or negative 1. If it's a 30 or a 60, you're going to get some version of root 3 over 3 or just plain root 3, depending on if it's what the x's and the y values are. So here's another question. What about something that's just not on the list at all? What about like 105 degrees? It's not there. But 105 is just 90 plus 15. Right? Well, I have a 90. Do I have a 15? No. But I do have a 90 plus. Could we create a 15? How? Half of a 30. Right? So I could take the sine of 90 and add it to half of the sine, well, depending on what it was. So now it's not quite that simple, but that's the basic idea. You can really create any number you want. Last year, we only used the nice angles. Well, when we're done with this chapter, we're going to move on to the harder ones. Well, what about 7 degrees? Can you create 7 degrees? I can. It's really easy. How would you do it? You could use negative numbers. Here's the easiest way. 7 equals 30 divided by 30 times 7. Right? So the sine of 7 is equal to the sine of this big mess. Okay? And there are other rules I'm not showing you on how to actually simplify that, because it's not actually like this. It's like that. So you're taking the sine of 90, but you have to figure out how to split 90 and 30 over 2, and that's where we're headed. And you can create any value you want using the unit circle. So I know it's kind of annoying to flip unit circles back and forth. Would you prefer me to put the answers on the board or a nice clean unit circle? How many of you want a unit circle on the board? How many of you want the answers on the board? 2 against 1. Thanks for voting. Okay, I'll put a unit circle up here.